Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier, question number 6, which is on the topic of forces. Rockets have been developed so that people who are not trained astronauts can pay to travel to space. Figure 9 shows the passenger module and the propulsion module of a rocket. The propulsion module burns a large volume of fuel. So the image shows SpaceX, Elon Musk's rocket. That's the first time I've seen in the exam paper. So the passenger module is on the top and the propulsion module is actually at the bottom. So the top bit is just where the astronauts are and the bottom bit is basically the fuel. So you can see the massive unit or the size of the rocket. Nearly 70% to 80% of the rocket is actually just for the fuel itself. So the rocket was initially stationary on the ground. Then the rocket accelerated upwards until it reached a height of 40 kilometers. Again, let's change it to meters. Multiply that by 1,000. That gives me 40,000 meters. The constant acceleration of the rocket was 6.48 meters per second squared. That's the acceleration. And this would be the distance, which is s. Calculate the velocity of the rocket at a height of 40, the same height. So calculate the velocity v. Use the physics equation sheet for 4 marks. The equation that you need is v squared minus u squared equals 2as. S is for distance, a is for acceleration, u is initial velocity, which is 0 here. So v squared minus 0, so let's ignore that, equals 2 times the acceleration, which is 6.48 multiplied by 40,000. And to find the value of v, you would square root the answer for the above calculation. In this case, I'm just going to write it as it is. 2 times 6.48 multiplied by 40,000. Do the multiplication first and then find the square root of your answer, and that will give you 720 meters per second. The answer is 720 meters per second. Question 6.2. Explain how the weight of the rocket changed as it accelerated upwards. Now, how does the weight change? Remember the equation, weight equals W equals mg. You can find this in the equation sheet as well. Weight depends on the mass and the gravitational field strength. So if the mass and the gravitational field increases, the weight will actually increase. Now, in reality, in the rocket, as the fuel is burned, you're going to have less mass because you're using up the fuel. So the mass is going down. And the gravitational field strength also decreases when you go up from the surface of the Earth. So when you go into space, the gravitational field strength is less. Because both the mass and the gravitational field strength is decreasing, the overall weight of the rocket also decreases. Hence the 3 marks. You need to mention all 3 parts. Weight depends on mass and gravitational field strength. Mass decreases as fuel is burnt. Or you could say gravitational field strength. I would actually include that as well. Gravitational field strength decreases with height. Therefore, the weight decreases. At a height of 40 kilometers, the rocket stopped burning fuel. The rocket continued upwards to a maximum height of 60 kilometers. Explain why the velocity of the rocket decreased between the height 40 and 60 kilometers. So let's say that's the surface of the Earth. And from there to there, let's say it's 40 kilometers, and the fuels are used up at this point. The rocket goes a further 20 kilometers. Now the question is asking, why does the speed decrease after 40 kilometers? So the rocket's actually going to speed up right up to the maximum point. Once all the fuel is burned, it's still going to carry on going for another 20 kilometers. Eventually, it reaches a maximum of 60 kilometers and then starts coming down, or basically falling down. Why does that happen? Explain why the velocity decreased. Now, the main reason is, if I draw a free body diagram, if that's the rocket, the weight of the rocket is still going to be acting down. Now, the reason initially it accelerates is because the fuel is actually pushing the rocket upwards, so there's a bigger resultant force. Once the fuel stops working, there is no upward force, so that force doesn't exist anymore once all the fuel is burned. So the weight is still acting downwards, so it starts moving down because there's a resultant force acting down. The gravitational force acts on the rocket, or gravitational force acts on the rocket is in the opposite direction to the motion of the rocket, and there are no forces in the direction that the rocket is moving. So the resultant force is towards the Earth. 6.4. At a height of 60 kilometers, the two modules of the rocket separated and the passenger module fell back to Earth. Figure 10 shows the passenger module falling towards the Earth's surface. You have two parachutes attached to the passenger module, and the main reason you have a parachute is to slow down the passenger module, otherwise it's just going to be too fast when it hits the ground. Using parachutes causes the passenger module to fall with a lower terminal velocity. Lower terminal velocity, remember, terminal velocity is the maximum speed. So if it didn't have the parachute, it'll have a bigger terminal velocity. With the parachute on, it's going to have a lower terminal velocity than if parachutes were not used. Explain why the parachutes allow the passenger module to fall with a lower terminal velocity. Why would it fall with a lower terminal velocity? Remember, if without the parachute, the air resistance is going to be smaller compared to the weight, and so it's going to speed up. Eventually, it's going to be equal. Now, with the parachute, on the other hand, the upward force because of drag from the parachute or air resistance is bigger. So that matches to the weight. Again, the overall resultant force is 0, remember, for it to reach terminal velocity, so it's going to be slower. Parachutes increase the effective surface area. So you need to mention surface area or area, the word area, to get a mark. So there is the same air resistance. The air resistance is the same at a lower speed. So resultant force is 0 at a lower speed with the parachutes open. Take a bit of time to understand what the marking scheme answer actually says, because it is a bit confusing for most students to actually grasp this answer. Anyway, that's the end of the video, because that's the end of the question. If you found this video useful, hit the thumbs up button and subscribe if you want to see more videos. And if you're interested in seeing videos for biology and chemistry papers, always leave a comment and I'll see what I can do about those. But my priorities at the moment is to go through the physics papers. Thanks for watching. Oh, by the way, I have done the 2024 chemistry and the biology paper as well for paper 2. Please check it out. I will put a link in the description or probably as a link at the end of the video. Thanks for watching again. Bye.